this video, I want to pick up where we left off in talking about the inertia tensor and its application to three-dimensional rigid body kinetics. So where we left off last time was that we had an inertia tensor that looked something like this, and remember that we had the moments of inertia, ix, iy, and iz, and the products of inertia in all these other negative terms here. Now, this was pretty messy and a difficult way perhaps to look at rigid body kinetics. So we kind of are in need of a simplification that would make our lives a little bit easier. And one of the things that we can do is, say for example, I have some rigid body. If I can split this rigid body along its lines of symmetry, that allows me to redefine the problem in a different way. So suppose I created or was able to represent this in terms of new coordinate axes, which I'll call, in this case, x prime, y prime, and z prime. By doing this, by splitting the object along its symmetric attributes, then I'm able to redefine my inertia tensor. And if I were to rewrite my inertia tensor, now it would simplify to ix prime, iy prime, and iz prime. And again, because of this symmetry now, my products of inertia end up canceling each other out. And I get a tensor that looks something like this. Taking this then and applying it to my angular momentum, I can write terms for each of my components of angular momentum. Which look a whole lot nicer than what I was getting before. So these new axes that I've defined, x prime, y prime, and z prime, are called the principal axes of inertia. And again, they allow us to kind of really simplify that inertia tensor and really simplify our definition of angular momentum. I should note here that for any rigid body of any shape, there is always some set of axes which can be defined as the principal axes of inertia. So it's not that there is ever a situation where that doesn't exist. There is always some situation where we can simplify this problem down. And it's convenient when we can visually see the symmetry of the rigid body in order to help us locate those axes. But if we couldn't, there is mathematical ways, mathematical calculations that we could perform in order to locate those principal axes. Doing that's a little bit beyond the scope of this course, but just to note that that is possible and that those axes always exist. All right, thank you.